Students, in today's video, we're going to be dealing with the theory of quadratic equation. Theory of quadratic equation. Theory of quadratic equation. So this is what we'll be dealing with today, of which we know that the general quadratic equation is of the form ax squared plus bx plus c equal to 0. Okay, it is equation because it has an equal to sign. That it is quadratic because the power is 2, the highest power is 2. So that is it. And quadratic equations generally can be solved in a nutshell. We can generally solve them using 4 different methods. The first method we can use in solving quadratic equation, we can use the completing the square. We can use completing the square method. We can use completing the square. We can use factorization method to solve them. And then we can also use graphical method to solve quadratic equations, and then lastly we can use the formula method to solve what? Quadratic equations. Okay, so next let's also recall that the quadratic formula, it's a formula of the form we have that x is equal to minus b plus or minus root of b squared minus 4ac over 2a. So for convenience purpose, we want to do some little work or substitution regarding to this quadratic formula. So we can, at this point, we may decide to say, okay, fine, let's make d to be equal to, we put it to be equal to b squared minus 4ac. Remember, this is called the discriminant, and we use this whenever we want to see how we can solve a quadratic equation without, to just obtain a solution without solving. So this is called the discriminant, and so that means this portion is gone. So what is left is the roots now. We can say if alpha is now minus b, okay, if it is minus b over 2a, all right, that is plus d actually. So if we name this alpha, that is root d, okay. If we say this is root d, remember d is this inside here. So, and if we now say, okay, let beta be the second root, that is minus b minus root d over 2a. Then we will now examine, remember that I'm actually teaching on the theory of this quadratic equation. So now let's examine what now happens along the line of this assumption or references. So now we notice that if we have the discriminant, that is d, which is all of these 4ac to be equal to 0, then what happens? We have that the root of that quadratic equation, which was x equal to minus b plus or minus root of d over 2a. Now if this goes to 0, it simply means that x is equal to minus b over 2a, which is equal to both alpha and equal to both beta. Do you see that? So that is when the discriminant is equal to 0. Now let's examine another one. Next, let's check when the discriminant root of b squared minus 4ac is less than 0. What happens? Then if it is less than 0, you know we have x equal to minus b plus or minus root of d over 2a. If this becomes less than 0, so anything less than 0 is actually a negative value. And if it is negative, what happens? You remember that alpha is going to be minus b. Alpha is minus b. So if this is negative, we're not going to obtain Well, so it's going to be plus or minus whether, okay, let's it still be x for the two of them. So if this is now negative, you notice something, that this is going to be imaginary root. Okay, so we're going to obtain two imaginary root, that is both alpha and beta to be what? Imaginary. Okay, so now let's now also examine when the discriminant is greater than 0. So if d is equal to b squared minus 4ac is now greater than 0, then what do we have? Then we have a situation where, okay, if it is greater than 0, then something, and we put it in this expansion, minus b plus or minus root of d over 2a. When this is greater than 0, so we are going to have two conditions. A conditions where we are going to examine, actually, d is equal to is greater than 0. That is the first one, where d is greater than 0 and is a perfect square. When it is greater than 0 and we obtain a perfect square, we have a condition, because if it is greater than 0, it's never going to be negative. There is a root for it. So you see that for there to be root of any number, is either that number is a perfect square, let's say the number is a perfect square, or maybe an imperfect square or non-perfect square, something that is not perfect, right? So, or an imperfect square, right? So if it's a perfect square, that is, if it's greater than 0, we can obtain when it is a perfect square. If it is greater than 0, we can also obtain when it is irrational and distinct. So it's either going to be what? Also irrational, though it will be irrational, right? And also what? Distinct. That's what we're going to obtain. So this is the first phase of this theory of quadratic equation. Now we'll take an example. So now let's take an example here. Let's take a first example. So the example here said, find the nature of the roots. Find the nature of the roots of the quadratic equation of the quadratic equation 2x squared minus 3x minus 20 equal to 0. Now let's solve this problem. So the problem says find the nature of the roots. So the quadratic equation always has two roots, but now we want to now see how to find the nature of the roots. So let's solve the problem. So first thing first is that you must recall that our discriminant, remember that if you are to set this, remember that your discriminant first is b squared minus 4ac, okay? And I think that's a major thing you need to remember. So from here you put out what is your a from this quadratic equation. So our a here is 2, our b here is 3 minus 3, then our c is minus 20. Okay, so now we begin to place it into our, okay, sorry, this is plus, so our b here is plus 3, actually positive. So now we are going to replace them into this discriminant in order to find what it is. So the discriminant is b squared, that is 3 squared is 9, minus 4 into, what is a? A is 2, c is minus 20. So let's see what the nature of this quadratic equation will be. So then we have the discriminant is now root of 9 plus, because 4 times 2 is 8 times 20 is 160, which is root of 169. And 169 is a perfect square, so it is actually 13, because 13 times 13 is 169. So you see, hence the roots are rational and distinct. They are rational and distinct. How? Because if you want to now check how are the roots rational and distinct, We will now carry the value from our discriminant and then place it inside here where we have that, okay, let me use alpha and beta instead of the x for the 2. So we have alpha is actually equal to minus b, okay, plus the root of the discriminant we got to be 13, and this is over 2a, which we know that our b is positive 3, so it's going to be negative 3 plus 13 over 2, where our a is also what? 2. So that is 10 over 4, right? So we have this to be 10 over 4, and 10 over 4 is actually 5 over 2, right? So you see, this is rational. So now let's check for beta. Beta is going to be minus b minus what we got, the discriminant, then 2a, which is same as minus 3 minus 13 over 4, right? So we have this to be negative 16 over 4, okay? Negative 16 over 4 is same as 16 divided by 4 is 4, right? Because 4 times 4 is 16, so we have minus 4. And minus 4 is also same as minus 4 over 1. So it's also what? Rational. But the major thing here is that they are what? Distinct. Alright, so let's take a second example on this theory. Now, we have a question here that said, find the nature of the root of this quadratic equation b. We have 3x squared minus 2x minus 2 over 5 equal to 0. So this is a quadratic equation. We should find the nature of the root, and the nature is actually gotten when we know what the discriminant is saying. Minus 4ac, right? So here we now get the value of a is 3, b is minus 2, then c is minus 2 over 5. Okay, so that's what we have here. So we substitute into the discriminants, and we have this b squared is going to be 2 squared, minus 2 squared is going to be 4, positive, minus, we have 4 here, so this is a, and a is 3, this c, and c is minus 2 over 5. So because of this minus minus here, it will become plus, surely. So let's create more space so we can simplify further. So here now we have okay, so this becomes root of, this is 4 plus. Now if you look at this, 4 times 3 is 12, then 12 times 2 is 24 over 5. 24 over 5. Okay, so that is we can simplify it to be, we distribute 5 times 4 is 20 plus 24 over 5. You know, it's same as over 1, and so I did times 5 times 5, so I haven't changed anything. So we have this to be root of 44 over 5. So having this to be root of 44 over 5, we notice that we are going to obtain irrational and distinct roots. So how is it going to be irrational and distinct roots? We end up substituting it into the expression, or maybe like I earlier did, let's find it separately for alpha and beta. And so alpha is minus b plus what we got, that is root of 44 over 5, then by 2a, right, which is minus b is, we obtain b from the equation to be minus 2, so that's positive 2 now, right? So minus and the minus is positive, plus root of 44 over 5, then by 2, our a is 3, so 3 times 2 is 6. So we have this, if we break it down, we obtain, we're going to see that we're going to obtain a final working for this, which is, of which this will end up to be what? Irrational number, right? It will end up in roots, so it will be irrational. Now let's look at beta is going to be minus b minus root of 44 by 5 over 2a, which is 2 minus root of 44 over 5 over 6. So this is going to be equal to, it's still also going to be irrational. So we obtain irrational, but the two roots are not the same actually, because if you add up this, it's going to be larger than when you subtract from this. Okay, so when you remove that is 2 minus this, so it's going to be actually less than 2. So but this one is going to be greater than 2. So this will be greater than 2, but this will be less than 2. So they are distinct, but they both are what? Irrational. So this is the first video on this theory of quadratic equation. See you in the next one.